My dear students, in this video, I am going to start a new chapter in 12th standard mathematics under State Board syllabus. That is chapter number 9, Applications of Integration. See, so far we have seen the 8th chapter in the 12th State Board syllabus, that is Applications of Derivatives, and finally we solved the problems under partial derivatives. Now I am going to start a new topic, chapter 9, Applications of Integration. This topic is very important for both CBSE and State Board syllabus students. In CBSE also there is a chapter, Applications of Integration you have. Before going into the topic Applications of Integration, I am going to just recall all the results in integration you have studied in your 11th standard. So formulas in integral calculus, results or formulas or formulae, whatever it may be. The formulas which you have studied in integral calculus in your 11th standard. I am going to recall all the results you have studied in your 11th standard. After that, we can enter into the topic. By recalling all the results which you have already studied are very important and are very useful to continue the topic. The first result, integral x power n dx is equal to x power n plus 1 by n plus 1 plus c, where n is not equal to minus 1. N should not be minus 1. See, before introducing this result, what do you mean by integration? Integral means, see, adding or integrating the splitted particles into a bigger particle. That is called integration. The smaller particles, after integration, by adding the smaller particles into a bigger particle, that is integration. Vice versa. That is conversely, that is reversely, differentiation is the opposite process of integration. Differentiation is splitting the bigger particle into a smaller particle. Splitting a bigger particle into a smaller particle is differentiation. Differentiate a derivative, or rate of change. The bigger particle should be split into a smaller particles is differentiation. Summing up of splitted particles into a bigger particle is called integration. Reverse process. Integration is the reverse process of differentiation. So you keep it in mind. Now this is the first result. I am going to introduce x power n dx. Integration symbol is this, integral x power n dx equal to x power n plus 1 by n plus 1 plus c. The c is the constant, integrating constant. This should be, c should be added in all the integral values. Why we are adding that c, integrating constant? Integration gives you the approximate value only. Indefinite integral, I mean, this is called indefinite integral. Integral x power n dx is integration, the lower and upper limit we don't know. Suppose this is called indefinite integral. Whereas if you have the limits integral a to b x power n dx, this a is the lower limit and b is the upper limit of the integration. Integral value should be integrated in between a and b. Suppose this is b and this is a. The entire part, a bigger part, by splitting the entire part into smaller particles and adding all these smaller particles into a bigger from a to b is called integration, and this is called definite integral. Definite integral having lower and upper limits. We have defined the integration between these 2 points. That's why it is called definite integral. In this integral, gives you the correct value of the integral values almost. Whereas indefinite integral should not give the accurate value, it may be approximate value. Therefore, we are adding some with the answer we have some more constant, integrating constant should be added for all the indefinite integrals. Whereas in the case of definite integrals, the integrating constant should not come. It should not be added or it should not occur. Now for indefinite integrals only, the integrating constant should be added in the answer. That is the introduction of C in the value of integration, or in just indefinite integrals only. That indefinite integral contains the integrating constant, whereas definite integrals, the integrating constant will not occur. Now, the integral x power n dx is equal to x power n plus 1 by n plus 1 plus c, where n, what is that? Not equal to minus 1. If it is minus 1 plus 1 is denominator 0, then what is that? Integral should not exist. That's why integral should not be, the n should not be minus 1. This is the result. For example, you will consider integral x cube dx. For this, the result using that, where n is an integer, therefore x power 3 plus 1 by 3 plus 1 plus c, that is your answer. So x power 4 by 4 plus c. This is the value of the integral x cube dx, indefinite integral. There is no lower and upper limits, therefore x cube dx is x power 3 by n plus 1 by n plus 1 plus c, x power 4 by 4 plus c. Suppose you will get x dx. Here, the power of x is 1. Therefore, our answer is x power 1 plus 1 by 1 plus 1 plus c, that is equal to x square by 2 plus c. Integral x dx is x square by 2 plus c. And one more thing you can write, integral, what is that? Dx only. In this case, there is no x power. Here you will get x power 0 dx. X power 0 is 1. Anything power 0 is 1. 1 into dx is dx. So integral dx can be expressed as integral x power 0 dx. Again by the rule, x power 0 plus 1 by 0 plus 1 plus c. X power 0 plus 1 is x. X by 1 is x plus c. Integral dx is x plus c. By using this result, you can consider these values. Integral x dx is x square by 2. Integral dx is just x plus c. Okay, by using this idea, suppose if n is a negative integer, for example, if n is a negative integer, say x power minus 3 dx. Here also use the same idea, x power minus 3 plus 1 by minus 3 plus 1 plus c, that is equal to x power minus 2 by minus 2 plus c. X power minus 2, that is minus 1 by 2 x square, you can write it as. This result is x power minus 2 is x 1 by x square, and this 2 is in the denominator, and minus becomes minus 1 by 2 x square plus c. So integral x power minus 3 is minus 2 minus 1 by 2 x square. Similarly, integral x power minus 4 dx is minus 1 by 4 minus 1 is 3 minus 1 by 3 x cube plus c. The same idea. X power minus 3 minus 4 plus 1 by minus 4 plus 1 is minus 3 by minus 3, that is minus 1 by 3 x. So like that, we have to use this result for solving these problems. Remember? These are the things you have studied already in your own standard. Just recalling the results only. Okay? Second one is integral 1 by x power n dx. 1 by x power n dx is equal to minus 1 by n minus 1 into x power n minus 1 plus c. Here n, not equal to 1. If you suppose n is equal to 1, 1 minus 1 is 0, the result should not exist. So n should not be 1 here, here n should not be minus 1. In this case, n not equal to minus 1, in this case, n not equal to 1. So this is the result. Into 1 by x power n dx is minus 1 by n minus 1 x power n minus 1 plus c. Okay. See how can we establish this result? Consider the example 1 by x power 4. That is, it can be expressed as x power minus 4 dx. 1 by x power 4 x power minus 4 dx. Just before I explain this is minus 1 by 3x cube plus you apply the result, you will get the same answer, minus 1 by x power 4 is n minus 1, 1 minus 1 by n minus 1, 4 minus 1 into x power 4 minus 1 plus c. This is minus 1 by 4 minus 1 is 3 x power 3 plus c. 4 minus 1 is 3. The same answer. So applying the result also you will get the result. Or otherwise by the previous idea you can integrate. So integral 1 by x power 4 dx is minus 1 by 3 x cube dx. By the result 1 minus 1 by n minus 1 into x power n minus 1 plus c. Using the result you will solve the problem. Okay. One more result, if you find the integral of root x dx, this is expressed as integral x power of dx. Root x can be expressed as integral x power of, that is again by rule x power of plus 1 by of plus 1 plus c, that is equal to x power 1 plus 1 by 2 plus 1 is 3 by 2 by 3 by 2 plus c. So x power 3 by 2 by 3 by 2 plus c, integral root x is x power 3 by 2 by 3 by 2 plus c, or that is equal to 2 by 3 into x power 3 by 2 plus c. You can write plus 2 by 3 into the numerator. If you bring it to this 3 by 2 into the numerator, it becomes 2 by 3 into x power 3 by 2 plus c. Okay? Suppose integral 1 by root x dx. You see the problem. This is integral x power minus of 1 by root x is x power minus of. Again by rule, x power minus of plus 1 by minus of plus 1 plus c. That is equal to x power minus of plus 1 is of by minus of plus 1 is of plus c. That is by 1 by 2 is 2. 1 by 2 if you bring it to the numerator it is 2. X power of is root x, 2 root x plus c. So 1 by root x dx is 2 root x plus c. This is another example. Integration of 1 by root x dx is 2 root x plus c. You remember all these ideas by using these two results only. Okay. So if you thorough with these ideas, you can understand the topic very easily. The result for both the topics integration involves the same results. Similar results of differentiation and integration results you should remember that are very useful for solving the problems. Without using the result or formulas, you cannot solve the problems. Third one. Integral 1 by x dx. This x, 1 by x should not be bring it to x power minus 1. You cannot express this as x power minus 1 plus 1 is minus 1 plus 1. X power 0 by 0. That is infinite. That integration terminates. It will not give answer. So for this integration, you have one result integral 1 by x dx. You cannot integrate this as x power minus 1 dx. If you like the integrated x power minus 1 plus 1 by minus 1 plus 1 does not exist because minus 1 plus 1 is 0. For that reason only n should not be minus 1 here. Here also n should not be 1. If it is 1, you should not apply the result. For that, integral 1 by x dx is log x plus c. This is your answer. Integral 1 by x dx is log x plus c. I already told you, integration and differentiation are reverse process. Suppose what is the derivative of log x? D by dx of log x, you know. Log x derivative 1 by x, you know. That's all. Integral of 1 by x dx is log x. That is your answer. So reverse log x derivative 1 by x. 1 by x integration is log x. You take this dx for right hand side 1 by x dx and d symbol become an integral symbol. Integral 1 by d. Derivative of log x is 1 by x, but integral of 1 by x dx is log x plus c. If you want, you can say. You add the integrating one with c. Similarly, derivative of sin x, you know cos x. Therefore, integral of cos x and this dx becomes sin x plus c. So, integral of cos x is sin x, integral of 1 by x is log x, integral of sin x is cos x is sin x. What is integral of sin x? You know, d by dx of cos x is d by dx of cos x is minus sin x. Therefore, integral of sin x is, you bring this minus sign this side, that is minus cos x. Minus cos x plus c. Integral sin x is minus cos x plus c because derivative of cos x is minus sin x. Therefore, integral of sin x is minus cos x. Reverse idea. Similarly, derivative of e power x is e power x. Derivative of e power x, therefore, integral of e power x dx is again e power x. The derivative of e power x is e power x, therefore, integral of e power x is e power x plus c. So, these are the ideas you have to remember. So, therefore, integral 1 by x dx is log x plus c. Fourth one, integral e power x dx is e power x plus c. Similarly, fifth one, integral e power minus x dx. Here also your derivative of e power minus x is minus e power minus x. Therefore, integral of e power x minus x is minus e power minus x plus c. Derivative of e power minus x is minus e power minus x. Therefore, integral of e power minus x is minus e power minus x. Okay? And integral sin x dx, just you can see sin x is minus cos x plus c, and I will write the answers here. Integral of sin x dx is minus cos x plus c. The seventh one. Integral of cos x dx is sin x plus c. Integral sin x is minus cos x. Integral cos x is sin x because derivative of sin x is cos x. Integral sin x. Integral tan x dx. You have studied in your 11th standard, this is log secant x plus c. Integral tan x is log secant x plus c. Next one, integral cot x. Integral cot x dx is log sin x plus c. Integral cot x is log sin x plus c. Next one, integral secant x dx. Integral secant x dx is log secant x plus tan x. Plus c. Log secant x plus tan x plus c. integral cosecant x dx. Integral cosecant x dx is secant x dx is log secant x plus tan x plus c. Integral cosecant x dx is minus log cosecant x plus cot x. Integral cosecant x dx is minus log cosecant x plus cot x plus c, or is again another result, log tan x by 2 plus c. This is log tan x by 2 plus c. Integral cosecant x has two results. One is minus log cosecant x plus cot x plus c, or log tan x by 2 plus c. Okay? And one more result, integral secant square x dx. Secant square x dx. You know, derivative of tan x is secant square, therefore integral of secant square is tan x plus. Integral of secant square is tan x plus c. Integral of cosecant square x dx. Cot x derivative is minus cosecant square x. Therefore, integral cosecant square x is minus cot x plus minus cot x plus. See, so far we have given 13 formulas, and further 14th one. Integration of inverse functions, that is next one, 14th one. Integral 1 by 1 plus x square dx equal to integral 1 by 1 plus x square dx is tan inverse x plus c. 15th one. Integral 1 by root of 1 minus x square dx. This is sin inverse x plus c. Integral 1 by 1 plus x square is tan inverse x. Tan inverse x derivative is 1 by 1 plus x square. Therefore, integral of 1 by 1 plus x square is tan inverse x. Sin inverse x derivative is 1 by root of 1 minus x square, you know. Therefore, integral of 1 by root of 1 minus x square is sin inverse x dx. Okay? One more integration, integral f dash of x by f of x dx. Integral f dash of x by f of x dx is log of f of x plus c. Log of f of x plus c. You remember, it's an important result. It is an application. The derivative of the denominator function should be in the numerator. This is log of f of x plus c. Integral f dash of x by f x dx is log of the denominator plus c. For example, you consider integral cot x. Integral cot x you can write it as cos x by sin x dx. Cot x you can express as by trigonometry cos x by sin x. This is derivative of sin x is cos x. So derivative of sin x is cos x in the numerator, f dash of x by f of x dx form. Therefore, the answer is log of the denominator, log sin x plus c. That's why integral cot x, log sin x we have seen already. Integral cot x is log sin x I have given. It becomes like using this idea only. Derivative of the denominator sin x is in the numerator cos x. Therefore, integral of f dash of x by f of x dx is log of the denominator, log of f of x plus c. Next one, integral f dash of x by root of f of x dx is equal to 2 into root of f of x plus c. 2 into root of f of x plus c. Here I given that one problem, integral root x dx is 2 root x. So integral root x, integral 1 by root x. Integral 1 by root x is 2 root x dx, 2 root x plus c. See, derivative of the denominator is in the numerator. Root of root x derivative, x derivative is 1. F of x derivative is f dash of x in the numerator. Derivative of x is 1 in the numerator. So it is of the form f dash of x by f of x dx is 2 times of root of f of x. So this idea is used in this result. The denominator derivative root x derivative is 1, which is in the numerator. Therefore, f dash of x by root of f of x is 2 into root of f of x. Okay, or one more result, you can write it as secant square x by root of tan x dx. You see this example, tan x derivative is secant square x. Tan x, f of x is tan x. Tan x derivative is secant square x. So f dash of x by root of f of x is 2 times of root of f of x, 2 times of root of tan x. That's all. The same idea. Derivative of the root function within the denominator is secant square x. Tan x derivative is secant square x. F dash of x by root of f of x is 2 into root of f of x. Therefore, tan x derivative is secant square x. Therefore, 2 into root of tan x. Like that, the results are applying. Next, these are the things you have studied. I am just recalling the 12th standard syllabus. Okay. Finally, the 18th result one is the integral f dash of x into f of x power n dx equal to integral f dash of x into f of x power n dx is f of x power n plus 1 by n plus 1 plus c. F dash of x into f of x power n dx is equal to f of x power n plus 1 by n plus 1 plus c. How can you use this result? So integral of what is that? Cos x into sin power 4x dx. See, derivative of f of x is sin x. Derivative of sin x is cos x, f dash of x. This is f dash of x. Derivative of f of x is sin x derivative is cos x. Therefore, it is of the form f dash of x into f of x power n dx is equal to, your answer is f of x power n plus 1. So, sin x power n plus 1. Sin x power n plus 1 by n plus 1 plus c, that is equal to sin power 5x, sin x power full power 5, sin power 5x by 5 plus c. Like that, x power n integral f dash of x into f of x power n. F of x derivative is f dash of x. This is sin x. Sin x derivative cos x. This power n is 4. Therefore, sin x power 4 plus 1 by 4 plus 1, that is sin power 5x by 5 plus c. That's all about the idea. So I will stop here. This you should remember all the 18 results so far. We dealt with the 18 results in this video. I will continue the remaining results in the next video. Thank you.